Okay, in this video, I'm going to attempt to run through two examples in your guided notes. So here are the parent functions, just flip in the pages. I'm going to do number 2 and number 4, simply because number 4 has all the elements in it. Even though they're both secant graphs, I think that they'll give you an idea. I'm going to do it on separate paper. So if you want to get a separate sheet of paper and follow along, then that way you can have good notes with all the elements in it. So here we go. This is number 2. I've got it copied. The first thing I notice is that it's a secant graph, so it's a 1 over cosine graph. Over here in red, I've got all the elements listed in your guided notes, and then I've got space to show all of my support work so that I can do my thinking and figuring. And if you want to take notes so you have maps to follow, please do so. So the first thing I like to do is identify the ABCs. Here, A is -1. Whoops, my pen is too fat. All right, here we go. Hang on. A is -1. Whoops, come back. A is -1. Now it's too skinny. Here we go. Let's see if I can get it just right. Okay, here we go. All right. A is -1. B is pi over 4. C is 0 and D is 0. So moving to the guided notes. Let's see. What do I have over here in my guided notes? Let's see, I can identify that I have and I'm looking at my notes, and I have recorded this video 3 times. I keep making mistakes, so this is the 3rd time. Nothing can go wrong. All right, phase shift, there's no phase shift. Vertical shift, there's no vertical shift. And I know that I'm going to have a stretch because A is -1, so I'm going to have a flip to this little graph. All right, moving on. Next thing I like to do is find the period. The period is 2 pi over B. So here it's going to be 2 pi over pi, or divided by pi over 4. That's 2 pi over 1 times 4 over pi. Pi's divide out, so the period here is 8. I like to do the X scale, and hopefully you'll see in this example why I like to do that. The X scale, remember, is just telling you how far to go when you plot your 5 points, how far to go between each one, or really how much to count between each one. So here the period is 8. So to divide that into 4 equal segments, that means I'm going to count by 2s when I get to the graphing part. And there's no phase shift here, but I still like to identify my starting point and the period so that I know where I'm going to stop. It just helps me make a more accurate graph. And I think now I am ready to graph this thing. So here we go. Drew myself a little grid right here. And in the middle, the midline is 0 and my amplitude is 1. So this is +1, this is -1, and I'll give myself a y-axis right here. Okay, so this graph, let's see, this is a cosine graph with a stretch and a flip. So it's a negative cosine graph. And it's got a few other little elements going on in it, which we have all the details for that. So I'm not going to worry about that. Let's see, this graph is going to start at 0. So let's give ourselves the 5 starting points. So I've got 1, 2, 3, 4, 5 points. I'll start at 0, and my X scale is set to count by 2s as I go across. So I'm starting at 0, I'm traveling 8, so I should end at 8. So as I'm labeling my points, I'm going to label by 2. So I'll start with 0, +2, +2, +2, +2. And now my little graph, I'm going to graph the parent cosine graph, and then we'll funnel in the secant graph. So this graph has a negative stretch to it. So that means I'm going to have my first point down at the minimum, and then I'll cruise back up to the midline, up to the top, back to the midline, down to the bottom. And I'll do this in a dashed way. And here we go. Here's my cosine graph, and I'll try to be neat and with this graph. And there you go. I guess it's not too bad. All right. Okay. Now, for the interesting part, or the kind of the newer pieces with this, the asymptotes. And I only graphed one iteration of this, or one cycle, the asymptotes. So this is where it starts to get a little bit different. Identifying the asymptotes. The asymptotes will occur where the graph crosses the x-axis or the midline. So here, to draw these in, I'm going to draw a vertical line through 2 and a vertical line through 6. And I missed it. So hold on, let me make that better. Vertical line, that's not showing up. Let me see, let me change that ink color. We'll go with this purple. This will be better. So here I've got a vertical line through 2. That's one asymptote. And a vertical line through 6. There's another asymptote right there. I still missed it. I'll try it one more time. There we go. There we go. Nailed it. Got it. Got it. Got it. Got it. Asymptote. Okay, here we go. So those are my asymptotes right there. This is important because it helps give you the domain of the graph, and you also have to describe the asymptotes algebraically, mathematically. So let me tell you what that means. To describe these mathematically, here's the first one. The first asymptote occurs at 2. And let me just go with Reading. The first asymptote occurs here at 2. The next asymptote occurs at 6. So the next asymptote number 2, I'll call him number 2, and I'll call this one number 1. They are 4 units apart. They're 4 units apart. So to describe that algebraically, I would say x equals 2. Let's see, for this is number 2. X equals, I'm starting at 2 and I'm traveling 4 units away. So 4n, and I would have to say that n is an integer. I'm going to move back up here to the spot where your guided notes would be. So in your guided notes, it asks you to describe the asymptotes. The way that I like to think of it, I like to take the first asymptote. So this one started with 2, and then the distance from the first to the second was 4 units. And that means I'm going to be traveling in increments or multiples of 4, starting at 2. And then you would need to say that n is an integer, and the capital letter Z is the abbreviation for integers in the number families. This is probably one of the most confusing things right here, and just take it for what it is. I'm going to do another example, and if this is the thing that is the most confusing to you, we can clean it up when I get back. All right, I'm going to move on and look at, oh wait, I forgot to do the most important part though. I forgot to draw in the reciprocal. I get so concerned with other things, I sometimes forget to do that. So now to actually draw the graph that you're asked to draw, I've got the cosine sketched in, I identified my asymptotes, but now I need to actually draw the graph that I was supposed to draw. And let me make this a little bit larger. And here we go. So now to draw this in, go to the minimum point, and the minimum point you're going to turn away. You're going to stay between the asymptotes. Minimum point, staying between asymptotes and turning away. Then go to the maximum point. You're going to intersect that maximum point, and you're going to stay between the asymptotes. So the bright pink, that would be the reciprocal graph. You would need the asymptotes drawn in, and just the outline of the cosine or the sine graph just helps you funnel in. It's not incorrect to have it there. I think it's a good learning tool, and it helps you, but just I get so carried away with all the other aspects that I forgot to actually do the graph that I was supposed to do. Okay, moving on, number 4. Okay, so number 4, let's see, I noticed that this is a 1 over cosine once again, and I'm also noticing that this is given in that bx minus c, so I'll have to deal with that in a minute. So let's go through the little process. We're going to rewrite this once we identify B and C and pull that out. So let's just go through the process, go through every single step. So the first thing I'd like to do is identify the ABCs. A here is -2. B is the coefficient on X, so B is pi over 4. And then C is going to be pi over 2 divided by pi over 4. So I'm going to factor that out. The way that I would factor that out is by dividing. And since this is a minus, that means this graph is going to be shifted to the right. And let's see, D is 0. So just kind of identifying all my players. D is 0. Let's go ahead and do the algebra here with this. So this is going to be pi over 2 times 4 over pi. And that's going to give me C is 8. That seems wrong. Hold on, I'm not having a deja vu on that. And let me look at mine. What did I do wrong? C is 2. Oh, C is 2. I did 4 times 2. Here we go. Sorry about that. C is 2. C is 2. Okay, C is 2. Okay, so this goes in the phase shift. So here the phase shift is 2, and it's going to be 2 units to the right. 2 to the right, because this is a subtraction right here. And that means now I can rewrite this. So this is -2 secant. And I'm going to bring the pi over 4 out by itself. And then I'm going to write that phase shift as x minus 2. And that's a little bit easier to look at. That helps me quickly identify the phase shift. Okay, next up, let's do the period. So kind of section this stuff off. Let's figure out what the period of the graph is. And that is the 2 pi divided by b. B here is pi over 4. So 2 pi over 4 is the same thing as 2 pi over 1 times 4 over pi. There's the 8 that I was looking for. The pi's divide out. So the period for this graph is 8. And vertical shift, let's see, there's no vertical shift. And I will have a stretch. So A is -2. I'm going to have a flip and a bit of a stretch here with this. Let's see, I think we're getting ready to identify the x scale. So here we go. I like to identify the x scale. And that's where you take the period and you separate it into 4 equal parts. So here 8 divided by 4 is increments of 2. And remember, this is how far I will count between points when I map out the first 5 initial points. And then I like to do a starting point and an ending point, especially when I have a phase shift. So this is my start point, and I'm traveling a certain period of time. And this will give me my end point for 1 cycle. So here my phase shift is 2. So that means this is also your new starting point. So the phase shift is also the new start point, if you want to jot that down. This is your new start point, which is important. Okay, here we go. So my new starting point is 2. My period is 8, which means 1 cycle should end at 10. And I think those are all the players that I need, and it's ready. I'm ready to finally graph. And here I've got my little grid drawn. And let's see, what was my shift? Let's see, I had no shift. So let's see, I'm right in the middle. And my stretch is 2. Got it. Here we go. So here, this is y equals 0. And I'm at 2. I'm at -2. Here is my x-axis, or my y-axis rather. Here's my y-axis. And I'm going to give myself my 5 points. 1, 2, 3, 4, 5. So in this one, since I have that phase shift, I can't use the origin as my first point. So my first starting point is, let me move this down a little bit so we can kind of see how we did with it. Moving this down, and here we go. I'm starting at 2, and my x scale said that I'm traveling in increments of 2. So just to remind you of that, here's my little x scale. It said, as I move from point to point, I'm going to add 2 each time. So I started 2 and adding 2, adding 2, adding 2. And as predicted, I'm starting at 2 and ending at 10. And this is a cosine graph with a negative twist to it. So that means when I start graphing, I'm going to start down at the bottom. So I'll start here, cruise to the midline, up to the top, back to the midline, down to the bottom. And I'm going to connect this up with a dashed line because this is just my cosine, kind of my little framework, and this is not the actual reciprocal graph. And before I get carried away with the asymptotes, I'm going to go ahead and draw them in, and then we'll draw in the actual graph itself, and then we'll analyze the asymptotes. So here, I'll do them in dark blue. The asymptotes are going to occur where the graph crosses the y-axis, or the x-axis at the x-intercept. So there's an asymptote, and here is an asymptote. And if I wanted to do more cycles, it would certainly be easy enough to do. I can never draw that straight. It would certainly be easy enough to do because I know how I would create successive points. Okay, here we go. Let me see if I can get this right this time. And okay, here we go. Fair enough. Okay. So to draw in the actual graph that I'm supposed to do, I'll go pink and I'll make him kind of fat. And here we go. I go to a maximum point and I cruise a parabolic shape away from the x-axis and trying to stay between the asymptotes. And here, minimum point cruising away, minimum point cruising away. And I could draw more so that you could see what was happening, but that's the general shape. That's what's happening here with this. So I've got the dotted green is the cosine parent that's been shifted over 2 units. I've got everything marked accurately. The solid pink parabolic curves represent the reciprocal graph that I'm supposed to do. So I need to see those, the pink curves, and I also need to see the asymptotes. Let's describe the asymptotes mathematically. And that's why labeling things, that's why doing the X scale and labeling these things out, this is when it becomes important. So here, the first one is at 4, the second one is at 8. So when I'm trying to describe this, I'm starting at 4, and then the next one would be 4 units away, which means that the next one would be 4 units. The next one would be at 12, and then the next one would be at 16. You would have one here, you would have one at -4. So they're going to occur in increments of 4s. And the way that you would describe that, looking at my notes, where did I put this? The way that I would describe that, I would just say it's just multiples of 4. I'm starting at 4 and I'm traveling multiples of 4. So each vertical line would occur in an increment of 4, and then you need to say that n is an integer. So I think with this, you were asked to describe the domain as well. So moving back up here to fill in the rest of your guided notes, you would mathematically describe them. For this, the first asymptote is 4, but it's just going to occur in multiples of 4. So that's the way you would describe it. And you would need to state that n is an integer. Now for the domain, use the braces, and x is a member of the real numbers such that x is not allowed to equal a multiple of 4. And this is why getting everything accurate, getting your scale accurate, that's why this is all important. And you would need to state here that n is an integer. Let's see if there's anything else. Oh, the range here for this. So the range, let's see, what did we have here with this graph? We had, let's say, yeah, we had the little shift here. So the range, this is actually really easy. -infinity, cruising up to -2, and you would union that with +2 going to +infinity. Try to mimic this with the other problems, and I will leave my answer key, extensive answer key for you all to compare things with. And then we'll take care of all of your questions on Monday.